What's up, everyone? This is Anthony Pompliano. Most of you know me as Pomp. You're listening to Off the Chain, simply the best podcast in crypto. Let's kick this thing off. Bruce Fenton is a dedicated scholar of anomalous phenomena focused on revealing the origins of Homo sapiens. In this conversation, we discuss what anomalous phenomena is, the history of meteor impacts on Earth, why geomagnetic reversals are important, the evolution of Homo sapiens, Bruce's theory on why extraterrestrial forces came to Earth on an artificial intelligence probe, how all of this relates to CRISPR technology, and how the media and others should be encouraging scientific experimentation. I fully recognize that many of these are radical ideas. I think it's important to hear all perspectives and expand our understanding and learning. I won't do many of these types of episodes, but when I do, they'll be due to a personal curiosity, and I'll do my best to make them informative and entertaining. I really enjoyed this conversation with Bruce, and I hope you do as well. Skirt, skirt! Want to know who has the best URL? Crypto.com. That's right, Crypto.com. They're a crypto platform with one goal, motherfucking mass adoption. That's why we're all here. We're trying to get crypto in every wallet. Crypto.com is helping people do that through buying, earning, lending, and card payment. Everything you could want at Crypto.com. Go help your boy out, tell him Pomp sent you. Download the app or visit Crypto.com. Pomp's got you, always. Ever wanted to get into mining and didn't know how? Don't worry, your boy Pomp's got you. Everybody got some electricity and Wi-Fi. All you got to do is go to coinmine.com, you buy a coin mine. It's like an Xbox or a PlayStation that helps you turn your electricity into Bitcoin. That's right. You purchase it, it shows up at your doorstep, you pull it out of the box, you plug it in, connect to your Wi-Fi, 5 minutes or less, you're mining Bitcoin. All you have to do is control it from the mobile app they provide, and then you receive over-the-air updates that add new coins and new features on a consistent basis. Kind of like how Tesla does over-the-air updates and updates the car software. Just you're updating your coin mine. Consumer mining made easy. That's right. Go to coinmine.com, tell them Pomp sent you, and thank me later. As many of you know, crypto investors store their digital assets on exchanges or in cold storage for long-term safekeeping. However, this strategy doesn't help them grow their investment holdings or build overall wealth. With the new BlockFi interest account, users can now securely store their Bitcoin or Ether at BlockFi and receive 6% annual interest paid monthly in cryptocurrency. 6% is an absurdly high rate. It's the best rate in the industry. I highly suggest you go check out blockfi.com/pomp. Again, that's blockfi.com/pomp to sign up and start earning crypto today.
Anthony Pompliano is a partner at Morgan Creek Digital. All opinions expressed by Pomp or his guests on this podcast are solely their opinions and do not reflect the opinions of Morgan Creek Digital or Morgan Creek Capital Management. You should not treat any opinion expressed by Pomp as a specific inducement to make a particular investment or follow a particular strategy, but only as an expression of his opinion. This podcast is for informational purposes only.
All right, guys, bang, bang. I am super excited to record this episode. We've got Bruce Fenton here with us. Bruce is been spending a lot of time focused on many things around human origin and extraterrestrial involvement, along with other scientific pursuits. So thanks so much for taking the time to come on and record this, Bruce.
Thank you. It's an absolute pleasure. Really glad to be here.
For sure. So before we kind of get into the fun stuff, I want to just start with your early life and your childhood and your background, so that when we talk about some of your work today, people have an understanding of the perspective that you're coming at this from. Where were you born? Kind of what was your early childhood like?
Sure. I'm from a small town in the southwest of England called Stroud, which is a rural town. And basically, quite a backwater place, not much happens. But I went to an English boys' grammar school. I've come from that kind of, I suppose, background, sort of middle class English background, product of that system. So some people recognise the kind of the accent. I have a bit of the Queen's English tone to my voice. And really, I got into these kind of obscure topics, I suppose, quite young. I mean, I had a grandmother who used to give me these collectible cards, that there were small collectible cards that would come with her tea leaves, and in them each one would have like a mystery, like the pyramids or crystal skulls, all those kind of the strange, classical strange stuff. And I just found them really fascinating, to be honest. And I suppose as time went on, I began to read in those topics, and that's where it developed from.
Got it. And so as you kind of went through school and everything, was there anything that you did in terms of like research, or was it really more just personal curiosity and entertainment to some degree?
Yeah, I mean, at the early age, it was more of just, a bit of a hobby. I suppose from probably around 20-ish, then I became a bit more serious about it as a research, area, and would, get more technical books on topics like, ancient civilizations, and also some of the I guess, psychical topics, paranormal, all of these subjects. Obviously, it's a university. I had the extra time, so you're not really weighed down with work and family. So I mean, I had the time to have this as a kind of a side project. And also had experiences of my own. I had a number of strange kind of psychical experiences, I suppose what we call sort of telepathy, knowing what people were thinking, including knowing people's names, that I would meet in a club and I would tell them their name, to total strangers. So those are the kind of events, of course, that then intrigue you as to, well, if it can happen to me, then it must be happening to other people. There must be a valid phenomena here that's worth studying. So it wasn't just because I found it intriguing, in an external way. It was also personally relevant.
For sure. And then where did you go to college, and kind of what was the focus of your collegiate or university study?
I basically studied IT actually in East Anglia, which is to the east of London. If people know the UK a little bit, it was Anglia Ruskin University. So I did 2 years of an information systems degree. So I took a higher national diploma in that, and went into, after that I was working in banking and some IT roles and stuff in the city. But alongside that, I maintained an interest in really all things mysterious. The full gamut from shamanic topics to, of course, as we've covered, some of the extraterrestrial, lost civilization. It started to, it starts to snowball. You find that most of these topics, they link into each other. So inevitably, if you explore one of them in any depth, you start to encounter all the others, right? So it becomes quite a web of subjects.
For sure. And today, I saw online that you describe yourself as a dedicated scholar of anomalous phenomena, and you're really focused on kind of the revealing the origin of Homo sapiens. But before we get into kind of that second piece, just talk to me about like what exactly is anomalous phenomena, and there's a whole kind of scientific community and body of work here. But from your seat, like what exactly is that work?
Yeah, really. I mean, if we look at most or all areas of science today, that within the existing popular consensus theories, you'll find anomalies, these little bits of data that don't fit the theory and that have as yet not been resolved by further research, further experiments. So of course in respect to, say, ancient history and human origins, we have a number of anomalies, and that's partly because of a lack of data. The further back you go, it becomes very hard to get the evidence, right? But in physics, we now see, for example, there's been a few events lately, and I will probably go into, with some craft that have been observed that seem to break the laws of physics. Now we'd say these are anomalous because they suddenly stop, and then they can suddenly they appear to be instantaneously at maximum speed again. That would be an anomaly, because as we understand it, craft have to slow down and speed up. So again, there's physics anomalies, biological anomalies. I'm interested in all of these really to some degree, and obviously only in some areas I have special skills which allow me to resolve some of them, or attempt to resolve some of them. So that's my focus, is really on anomalous science. You could say the SPR, the Society for Psychical Research, they deal with anomalous phenomena, and probably one of the more famous organizations that they'll research the paranormal and psychical type claims, and they'll apply scientific rigor to testing these claims to see if they can find a real world tangible solution for why certain things seem to happen, which we don't fully understand.
For sure. And I think that, for those at home who are unfamiliar with this, when we talk about that scientific rigor and some of the associations and things like that, there's, I think probably one of the larger ones is the Association for the Scientific Study of Anomalous Phenomena. That's founded in the 80s, right, in the UK, and studies everything from ghosts to crop circles, aliens, UFOs, kind of all of these things that I think have entered into the mainstream culture in more kind of mimic type or comedy, right? It's kind of like the jokes and kind of personal curiosity, but no one would ever openly admit in a traditional professional corporate environment, hey, I believe in ghosts, I believe in aliens. It's kind of taboo a little bit, but there's always, some form of truth in this stuff. And I think that, it's important for people to really understand that there's an entire community of academics, of researchers and scientists who are dedicated to studying this stuff, of which you are really attacking kind of a subset of that work.
Absolutely. And really, there should be no area of human experience or human observation which is beyond the remit of scientific investigation. So I think it's a sad fact that we ever developed this kind of farcical kind of joke approach to certain areas of human experience. Because if hundreds of thousands of people report seeing a ghost or report seeing aliens or whatever it is, that is a valid phenomena for scientific research, right? No matter what the final conclusion of that research is, even if it's that we have a mass delusion, because a mass delusion would be a fascinating discovery, right? That there's 100,000 people suffering from some rare brain condition that causes them to see the ghost of, King Henry VIII, right? That would be an astonishing scientific conclusion, wouldn't it?
For sure. And look, I've been pretty clear with folks that, my personal interest in a lot of this work and really kind of around this idea of intellectual life outside of Earth comes down to the idea that science is supposed to be experimental. Right, there should be no sacred cows. The idea of forming a hypothesis, putting it through that scientific rigor, and being comfortable coming out on the other end with whatever facts and conclusions are there. Right, so not saying I'm going to reject science, but saying instead I have a thesis that I'm willing to put through scientific rigor. And when I come out the other end, I'm open-minded as to what that conclusion can be based on those facts. And I think when it comes to extraterrestrial intelligence and life and the UFOs and kind of all of this stuff that I'll just call, kind of outside of Earth, I think that there's a lot of people who don't have that open-mindedness. Right. But as a friend recently told me, look, one of the greatest scientific breakthroughs that we could have in our lifetime would be the discovery of intelligent life outside of Earth. Right. I mean, that is an inflection point in both the Homo sapiens on Earth, but also in the trajectory. Right. If all of a sudden we know that there are other people out there, we can confirm that, we know where they are, et cetera. I think that it really would not only expand the thinking of people, but it would change the way that we do things or think about things and plan, which would obviously be pretty serious stuff.
Yeah, absolutely. I mean, it could rewrite the sort of the software of the brain in a way, the way we think about ourselves, the way we think about the future of our planet. The way we go about certain areas of infrastructure would change. That just knowing that we are not alone and that there's whether already or potential to connect with other intelligences, I think would be an enormous rewrite for a lot of our thinking. I mean, perhaps probably the two biggest questions out there in science and philosophy are does any element of us survive death, and are we alone in the universe? I mean, there's not many other questions that are on par with those, right? I mean, we all at some point will probably ask those two questions.
For sure. And I think there are, the way I see it is that both of those questions are really important. Everyone does ask them at some point. And most people have a foregone conclusion or assumption in their head, right? So they either believe that there is some afterlife or they don't, and they either believe that it's likely that there's other intelligent life or they don't. But I don't think that those assumptions disqualify the importance of the scientific rigor to actually get confidence in a conclusion. Right, to be able to confirm, yes, there is an afterlife or there is other life out there outside of Earth. Again, it produces a level of confidence and kind of finite answers that again change the behavior and understanding that humans have today.
Absolutely, and one of the things we know as well in the scientific and the tech world as well is that sometimes if you know that there is something out there which is possible that you can't do yet, right? But you know, say a competitor can do something, or you see a technology, right, which is being used in another nation you don't have. You know it's possible to develop it, right? So suddenly, if you have a team working on it, they are reinvigorated by the fact that, hey, someone else can do that, then we can do that, right? So if we know that there is intelligence out there and we detect them and we start to learn something about them, we find that they have, let's say, certain technology, certain knowledge of science, and we say, hey, that's really a radical rethink of what we assumed, what we thought was possible. That is going to really change how we go about developing new technologies, right? Because if we know civilization X can create, such and such a machine, then we can, right? So I think we're going to see that happen as long as we can, establish that there is something there and they have these technologies. That would really change the way we go about developing future tech and things like that as well. So it could, I think it's going to have an amazing impact. And of course, I'm underlying this. We'll get to, obviously, I'm arguing that is a current real world situation, right? That we have evidence that these kind of things are, that there is intelligence, right? If we look at some of the things that are happening at the moment, of course, we have recent events, which suggest that technology is operating right in our atmosphere, which do defy some of our understandings. Now, whether they're extraterrestrial or whether they are some unknown operator, those are going to inspire people to replicate, right? We're going to have these tic-tac things, whatever they're being called. People are going to look at those and say, well, hey, how do we stop it, immediately and then suddenly change direction? I'm sure that's already happening. I'm sure that's been worked on probably since the first detection, right? So if there's ways of studying other elements of that technology, now assuming it's, again, probably not human-made, then we're going to be able to, I think, start to chase whoever it is that's doing this and try to do catch-up, start to develop some really astonishing things.
Yeah, and what you're really talking about is it's kind of like the Roger Bannister effect, right? That no human had ever run a 4-minute mile. All of a sudden, Roger Bannister runs the 4-minute mile, and within 1 or 2 years, it was like 20 people did it.
Yeah.
Right, and it was just simply the belief that, hey, this is possible. Another human has done this. Broke open the floodgates, if you will.
Yeah, absolutely. I've heard of experiments where they've done this, where they've had teams of scientists have been given almost like, a fake video of something to show them that it's possible, and that it's changed the belief set of the team, right? Because it's like, well, hey, look, someone else can do it, then you can. And then they think, oh, right, yeah, we must be able to, whereas beforehand they would have assumed it was impossible, and they've gone on to develop that. Now, I can't remember the specific case where I read that, but obviously, again, it does seem that you're able to change people's thinking. I mean, that seeing is believing, right? That we will say it, but if you can see something else happening, well, you're going to believe it. And this is why we're seeing now, of course, a change in what's being called the UFO subject, that we're seeing things that now people are forced to rethink a lot of assumptions. And we can go a little bit into that. Should we talk a little bit about the recent videos, go a bit into detail with that? Or
for sure, yeah. So let's, before we get there, what I want to talk about is, let's go kind of chronologically from what I'll call the beginning of time, right? But really what that is pre-human, right? There were pretty well confirmed, pretty well accepted dinosaur life on Earth, right? And this is a whole host of various types of creatures, many of them that don't exist today. And the first kind of thing I want to talk about is this idea that there is one theory that is pretty well accepted, that there was a meteor strike into Earth. Some estimate that it was as much as 65 million years ago. right? So we're talking incredibly long time ago. And that meteor strike hit, and a very big piece of it hit in the Yucatan, which is in Mexico. And when that happened, it basically created such an impact that there was a bunch of fire and dust that was able to block the sun from actually getting into kind of the crust of the earth, right? Or actually hitting Earth in the way that we think about it. And due to that blockage of the sun, there was a drastic cooling of temperatures on Earth, and then that ultimately led to the extinction of dinosaurs because they just couldn't survive in that climate. One, just are you on the side of, hey, that is valid? Are you on some other theory there? And then talk to me a little bit about the science and the understanding around just the mechanism of a meteor impacting the Earth, and kind of, we'll use that to then get into some of the other work that comes in more recent times.
Yeah, I mean, I'm definitely, I suppose we call a cataclysm proponent, in that, a lot of, for a long time, geologists and evolutionary biologists have been very keen on cataclysm as drivers in science. I mean, historically, there was a lot of rejection of the idea that cataclysm play a huge role in the story of life. But we know today that they do. We know that there's been mega events, as you say, like the dinosaurs were essentially eradicated, or most of them, certainly the larger dinosaurs, and the remnants were forever changed. We have obviously species that arise from them, but the large dinosaurs essentially died off. And the mammal age really began because of that. So without an event like that, would mammals have got their foothold? Would we have started on the path to humanity? Probably not. We may have later on, maybe with the help of a different cataclysm. But without the removal of the top dog, the dinosaurs, it's hard to see that we would have ever developed, right? So we can see the importance of these cataclysms, and go back further, and we have others. We have there's the Great Dying. There's when the seas no longer moved in the way they do today, so the oxygen levels changed. We've had all these different kinds of problems where there've been huge die-offs, and those have absolutely shaped the environment for us and allowed for our development. So I think, I'm on board with that. These cataclysms were not only valid and real, but hugely important to our story, even though some of them occurred hundreds of millions of years ago. That they still have shaped the world to where we are now, and allowed us to become, if you want, at least for now, the sort of top dog.
For sure. And in terms of the meteor impact, this really is, for those that have no scientific understanding or haven't looked at it at all, it's really just the idea that there are rocks or debris that are floating around in space, and it's a collision. Right, they're simply they're on a trajectory that ends up intersecting with the Earth, and it is able to make it through the atmospheric kind of pressures and chemistry, and ultimately strikes the crust of the Earth. Right? Is that a fair way to kind of describe what's going on with those meteor impacts?
Yeah, absolutely. Yeah, we've got a lot of debris out there that's orbiting the sun, as we are at various distances. Obviously, we have the Oort cloud much further out, but we have the asteroid belt, which is nearer to us. So some of these objects will come into the inner solar system at times. We have, of course, comets as well on larger elliptical orbits. But this is all material that's within our solar system, and it's all essentially orbiting the sun. So yeah, every now and again, the orbit of one of these objects will just cross with us, or will be moved by coming close to the gravity of, say, one of the larger planets like Jupiter, and it will destabilize an orbit, and that we'll end up with an impact event. And we know that roughly every 1,000 years we're supposed to get a fairly significant strike, but it's every 100,000 years or so that we get I guess a really large, maybe a mile across kind of chunk possibly coming into us. Those are obviously much more irregular. The smaller chunks, yeah, we do, every 1,000 years or so. Again, this is an average. We'll get something that will, could take out a town or something, if it landed in the wrong place.
For sure. And so there are some very well-known meteor strikes, obviously, like the one in the Yucatan. But then there are ones that are only recently either being discovered or less popular. Before we started recording, we were talking about one that was discovered in Antarctica, right? And it's this idea that these researchers from Heidelberg University were able to gather these tektites, I think is how you say it, and they were able to find these in a whole bunch of different continents. But ultimately, there is this massive meteor that appears to have struck Earth and specifically in the Antarctica region that created an impact similar to that of which ultimately killed off the dinosaurs.
Yeah, that's right. I mean, as part of my current research project, I was, for reasons we'll come to, I was focused on a period around 780,000 years ago. And it turns out that there was extensive widespread destruction from a number of impacts, asteroid impacts at that time. Then you've got at least one that hit the Americas, another one in Africa, another one down Oceania, Tasmania, and this really big one which hit Antarctica, and which one of the craters from that chunk is 200 miles by 200 miles. So I mean, if people imagine the scale of that. So we're talking about a global bombardment, absolutely devastating effects that you would have had, extremely powerful tsunamis, and obviously also earthquakes. You have dust thrown up into the atmosphere, which causes cooling. What they think is the impact, the effects were lessened by the fact that it was an ice age at the time. So, for example, the hits that hit Antarctica obviously went down into the ice. They did melt quite a lot of water. They rose to sea levels. But things like tsunamis are drastically reduced, right, by the amount of sea ice that you've got. So there were some factors that you could say allowed life to weather this storm better than during the impact that wiped out most of the dinosaurs. So you could say we were kind of fortunate in a way that this was happening during an ice age and not at any other period.
Got it. And so explain a little bit more this idea that the tsunamis can be reduced by an increase in ice. It's just literally taking the liquid and putting it into a more kind of ice structure, and that means that there's less water for the tsunami?
Well, basically, yes. Some of the energy is going to be dissipated into the huge chunks of ice, and the fact you've got sea ice as well covering huge amounts of the ocean. A lot of the energy that would normally go into the wave is being dissipated into that ice as it radiates out. If you imagine this wave, obviously it's connecting with ice, so it's losing energy into the ice. So unlike where if you've just got open ocean, that wave moves fairly freely. I mean, it's still losing energy as it goes, but not to the degree where you've got enormous stretches of ice out there and icebergs and so it can be hitting all of this solid material as it goes and dissipating energy. So in that respect, it was lucky. It wouldn't have ended up perhaps with these kind of kilometer high waves coming inland and wiping out entire vast regions. It would have been significantly reduced. I mean, the impact of dinosaurs, you would have literally had like waves that were coming a couple of kilometers high or more. I mean, I may be under exaggerating it. I know that they were certainly enormous waves once they came onto land. The kind of energy you're dealing with an object, say 2-3 miles across, hitting is just stunning. It's meant waves that go around the world, multiple times. So sonic booms that go around the world multiple times. Firestorms. Of course, the dust that's thrown up. You get simply a nuclear winter. I mean, it sort of boggles the mind to imagine the level of destruction that you're talking about. And there may be other secondary effects, which also have turned up in my research, is that it's possible that some of these impacts actually initiate things like magnetic reversals and other unexpected phenomena that comes out of them, right? So they're really, really, destabilizing for the ecosystem.
Yeah, and so you just mentioned it. So let's go talk about the geomagnetic reversals. I know nothing about this, so just kind of describe what exactly is when you say geomagnetic. What is that, and then what is the idea of a geomagnetic reversal?
Sure. I mean, the current understanding is that due to the movement of molten iron in the core of our planet, and also molten lava, that the movements of this material are causing electromagnetic fields. So we have this almost like a dynamo effect, that the Earth is constantly generating and regenerating its own electromagnetic fields. Now, these extend out into space, and they have a kind of beneficial effect in some ways. They do block some of the cosmic energies that would come into our planet. So they act in a way a bit like a shield for our planet, right? Obviously, we also use them for things like detecting where magnetic north is and all the rest of that. But they have this effect in space as well. One of the problems you get every now and again. And I say every now and again, usually it's supposed to be roughly every 200,000 years. At one point, it's around every 200,000 years, there would be a total reversal, a flip from north and south. So they would flip over. Your north would now be your south, south would be north, and the exact position of the north and south poles would also shift a bit during this process, right? So the last time this fully happened was again 780,000 years ago, the period we touched on. But there's been many of these reversals, going all the way back to the beginning of our planet. And when they occur, the fields will weaken considerably first, and this allows cosmic radiation, cosmic energies to come into the system. And now there are thoughts that this itself may be harmful to life. Obviously there could be more cancers. There's it could be severe impacts on plant life, which then of course has an impact on other larger animals. So these events are problematic. Now, if it was to happen in our modern age, right, which they think it may be underway now, there's signs that the poles they're moving quite rapidly. They've been weakening considerably over the last few decades, right? If there was let's say a really fast reversal, we would have extensive problems because, of course, it's going to impact all of our high technology, right? All the electric fields that we utilize, right? We're going to have a problem. So this could impact all of our satellites. Again, if you take out our satellites, right, most of our high tech world would sort of crumble, really, right? So it is something that is monitored, carefully. There is a concern. We don't expect it to be so fast as to be that, next year, suddenly it flips. Usually it's over centuries, right? I mean, some of them have taken thousands of years, but we know the shorter ones have been over, a few centuries. But yeah, so these are essentially, again, mega events that happen on a fairly understood cycle.
Got it. And so how well accepted is the idea that these geomagnetic reversals occur and are important to pay attention to?
Yeah, they're well established because what we can do, you can find the reversed fields in rocks. So when magma is produced, say, in an event, and when it solidifies, it will solidify with the field direction that was current at that time. So when geologists look at ancient rocks, they can find, that at different periods in time, the magnetic field in those rocks is opposite to the direction that we have now. And so over time, they've been able to pinpoint fairly accurately when these past reversals have occurred. Now, the last complete one was 780,000 years ago, but there's been wanderings of the poles, there's been partial reversals where there's been weakening and stuff, but for whatever reason, we haven't had one since then. It was understood that they would be on roughly every 200,000 years as a cycle, but something disrupted it at that point, right? So it's never bounced back to the expected cycle for some reason.
Got it. That makes sense. Okay, so let's go to kind of the origins of human history, right, or the Homo sapiens. How long ago are we talking about?
Right. I mean, when you go to the earliest hominins, now the humans are essentially part of the hominins group. Okay, so all hominins are humans. So we tend to think of humans as us, but that's a bit of a misnomer. Essentially, the earliest hominins lived around about 6-7 million years ago. Now, these would have been, you could just about recognize them as being, a human relative, but you're definitely thinking more of a kind of Planet of the Apes. These were more like ape men, right? So the Australopithecines, for example, if you look at them, they were fairly short, like 4 foot odd, and then they've got small brains, like chimp-sized brains, but they have certain features to the skull and to their anatomy that tells us they're on their way to being more like us and less like chimpanzees and orangutans. So they have distinguishing morphology and cranial capacity that is increasing. They are on their way towards it. But these definitely, you wouldn't think of them as being, like if they got on the bus, you wouldn't be like, that's a normal guy, I'll sit next to him. They were quite recognizably more like ape men. It took several million years for the forces of evolution. There's many different ones actually involved. And when we think of natural selection, of course, is best known force that essentially, if you're suited to your environment, if you're well suited, you're more likely to have offspring. If you're not, you tend to die off, and that's natural selection. We talk about mutation, that there are random and non-random changes in the genome, which sometimes give new abilities, which are beneficial, or sometimes they're harmful, and that these again have a role in who gets selected to be killed off, who survives. But there are others. We now understand that there's things like we have these feedback loops in epigenetics where you can be changed by your environment within a lifetime, and that can be passed on to at least a couple of generations of your children. So if you go through a famine, right, your system will change to adapt to that famine, the way you burn energy and so. But that can also be passed down so that say your grandchildren are no longer living in famine, but aspects of their biology are still adapted to being in a famine, right? So these strange sort of very fast changes that can occur. We also have other things. We have like translocation. We have movements of information in the genome, which just sort of jumps about, these translocations, which again, these can change important aspects of an organism. So we're starting to realize evolution is far more complex than simply selection, right? That's what I'm sort of getting at. And that due to these processes, we end up with a much changed, ape man, if you like. By around 2 million years ago, we have the beginnings of Homo erectus. Now, this will be a recognizable human relative. That it's, we're starting to get the height, we're starting to get a larger brain. It's certainly a lot smaller than ours, about half the size. But we're getting the features that would be more in common to our own, species. And they're really where the human story gets interesting, because Homo erectus are the first of these hominins to be really, really global, more or less. We have them all throughout Eurasia. They're all the way down to Southeast Asia. There's been a couple of skulls found in the Americas, which appear to be Homo erectus, but they haven't been well studied. So at the moment, that's, you could say, is controversial. You can't say outright that Homo erectus were in America because, the science hasn't been done on those. They're just anomalies, again, my favorite things. And then we have some evidence that they moved through the islands of Indonesia and Southeast Asia, that we have them out across many of the islands. Flores has tools on it that date to over 1 million years ago. So Homo erectus is really the first global human, right? And then there's further evolution goes on from there. Our own species, Homo sapiens, we don't start to emerge until around about 800,000 years ago, roughly.
Got it. And the way that I look at this, and again, this is coming from someone who is not nearly as educated on the topic as you are, is there's really 3 buckets of beliefs or story of the human origin, right? There is what I'll call the evolutionary one, which is we evolved out of apes, and there's very kind of scientific reasoning and explanation as to how Homo sapiens eventually, kind of were the product of that evolution. Then there is what I'll call more of a fictitious or religious kind of a story, and this really is tied to the, and I'll probably pronounce it wrong, but the Anunnaki. But this are, these direct descendants from the gods and goddesses, and they really had come down to essentially decree the fate of humanity, right? And this is depicted in a lot of the Mesopotamian art, and kind of, again, very similar to what we would consider like religion today. And then there is this hybrid that I think you are probably much more into with some of your research. But before we get to your specific research, one of the debates that I find fascinating, one of my favorite books is Guns, Germs, and Steel by Jared Diamond. And I think that there's now starting to become a debate as to were the early humans as we know them, was this more in the continent of Africa? Is this more in the Asia and Australia region of of the world. Kind of how do you think about the geography of the origins of humans, and kind of which camp do you fall into?
I mean, well, I have a book on the topic. I wrote a book called The Forgotten Exodus, the Into Africa Theory of Human Evolution, and the key being there into rather than out of, because, I went through the literature, again, through the academic studies, look to see who is the leaders in these fields and to find out, what really happened. And I had reasons to do that. I was involved in some research in Ecuador, a mysterious megalithic site there, which seems to be connected with a group of people called the Lagoa Santa, which are I would say is the earliest modern humans in the Americas. They were down in Brazil at Lagoa Santa. It seems to be 40 to 50,000 years ago. There's a number of sites there, rock shelters, whatnot. It didn't add up with the conventional recent out of Africa, because these turn out to be kind of Aboriginal Australian morphology type people. So they shouldn't really be there in the conventional model, where now, if people are sort of familiar, the idea is that supposedly modern humans came out of East Africa in a wave around about 70,000 years ago, and then populated, obviously, Eurasia, eventually Australia, and last of all, America, right? It definitely isn't supposed to be like Aboriginal Australians, down in America sort of 50,000 years ago. So this is what led into my research. What I found is, and I've packed this up with all solid peer-reviewed papers and whatnot, I don't go out and do archaeology, but what I found is the evidence really points to a Homo sapiens population that is widespread. Now, when I say Homo sapiens, I say very archaic, very, very early Homo sapiens, who maybe would even be given a different name, but we haven't given them one yet. But from around about 700,000 years ago or so, we have these very archaic ancestors who are widespread. They're not just in Africa. They are all across Eurasia. They are down into Southeast Asia, I would say in Australia. The evidence has been removed by huge sea level changes. So we've lost a vast amount of land down in Southeast Asia and Australia. And also there's no reason why they wouldn't have reached the Americas. Okay. So I would say we have a vast population. And then what we have over time is climate changes. We have obviously cataclysms, all sorts of things which will change the locations where you'd find the bulk of these people. So they move both into Africa, out of Africa, probably into the Americas, out of the Americas. As climate shifts in places, or whether, if there's a benefit to going somewhere else, there's more food, humans move. We know that one of the most things about our species is we're highly adaptable, we're highly mobile, right? We also find that this ancestral population begins to diversify. We start to get the early Neanderthals, Denisovans, but they're all coming out of this lineage, the large-brained, what I would call the ancestors of Homo sapiens, and that these are, in my view, subspecies, which a number of scientists now recognize that what we're really talking about is Homo sapiens neanderthalensis, Homo sapiens denisova, and Homo sapiens sapiens, right? Because we can all interbreed. We know that. In fact, most of us have some level of Neanderthal or Denisovan or a mixture of that and other ancient hominids in us, right? Because essentially we're one species, we don't have a problem interbreeding. There's minor issues. It does seem sometimes that there may have been some problems, but essentially we know that it was successful. And that basically what happens is at one point there is a cataclysm, and this is at 73,000 years ago, right, which is the Lake Toba supervolcano down in Indonesia. And the effects of this are another one of these nuclear winter type cataclysms, but it's fairly limited to the northern hemisphere. Now, this is eradicating life all across the northern hemisphere. It's cooling the temperature, and it's already during an ice age. You get acid rain, plants are dying. Plants die, animals die. If animals die, humans that depend on those animals and those plants die. The water is poisoned, right, with sulfuric acid. So you can imagine this is a cataclysm on an immense scale, right? What we have is a die-off of most of the hominins of Eurasia. Now, some of them are pushed to the west and some are pushed to the southeast, i.e., if you get below the equator, you're okay. So if you can get down into Ireland, Southeast Asia, and to Australia, you're all right. And if you can cross the Bab el-Mandab Straits and into Africa from the Middle East, Yemen basically, if you can get across into Africa, then again, if you get to sub-equatorial Africa, you're safe. Now, this is exactly what the evidence shows. And we have a problem in science right now where there's a dogmatic approach that recent out of Africa is a holy cow that cannot really be questioned. Every article on the subject will start with, We know that 70,000 years ago, modern humans walked out of Africa. The rest of it we're still thinking about, right? But that bit is always beyond question. Now, when you do question it, you find that the evidence does not support it. And in fact, it's very clear we have refuges in Australia and refuges in sub-Equatorial Africa. And after this climate event dissipates around 55, 60,000 years ago, humans begin to repopulate Eurasia, right? But we were there before. It's a repopulating event.
Got it. And so as you think about the evolution from that origin point, this is really where I think your research, you've come to the conclusion and have a whole bunch of evidence that we'll talk about. You kind of have this like divergence from the traditional thought of the evolution. Maybe just start with kind of what the conclusion is, and then we'll get into kind of what that supporting evidence that you have and the work that you've done to kind of back it up.
Sure. It's most basic. I go along with, you could say, the evidence for evolutionary processes, as you can see, as I've sort of said there. I'm not disputing that we have these various pressures, and there's various factors of how the DNA code itself functions that cause evolution in species, right? So I'm not contesting that per se. So the difference in my work is I say that up until around 780,000 years ago, that as best as we can say, it's largely understood evolutionary forces at work. Now, that doesn't mean that there's nothing else going on. By just saying the evidence is not strong enough to flat out say anything else happens. I do want to clarify one thing, though, for people who aren't familiar with the idea of panspermia, that, I am a panspermia theorist, if you like, that I accept the evidence that DNA itself arrives on this planet from space, that it doesn't emerge out of a rock pool here, that life, isn't just coming out of the dirt. That's not my position, that I agree with a number of very well-respected academics who have theorized this. It's not something I've come up with. The idea that DNA is a true code, that you can even think of it as a terraforming technology, right? That you spray little pills full of genetic material onto a planet. You come back, in a few minutes, you're going to have life, okay? Because that's what it does. It adapts to its environment, changes that environment, produces new gases, a new surface for the planet. That's my position. I go along with that. So I think DNA contains a true code, and that it's extremely intelligent. Essentially, you could think of it as AI, right? And like artificial intelligence. Because if it's being created by someone out there and has been sprayed down here, then to some degree, I would say it's a true AI, right? But so you have this code in there, which we don't fully understand what it's doing, but it seems to adapt to things. It's very intelligent. It guides our adaptation. It guides our evolution. So that's an important consideration. However, at around 780,000 years ago, we see a clustering of anomalies, right? And now I love anomalies. That's my thing, as we said earlier. So when I see those, I think, what the heck is going on here? Why is it that science is stumbling over something? And they say, look, we know that in the fossil record, at around roughly 800,000 years ago, we get a sudden acceleration in skull size, in the cranial capacity of early humans. It just absolutely rockets upwards. Okay, beyond any relationship with body mass, index, it just suddenly starts rocketing up. That was long understood, but what we didn't have before, of course, was genetic technologies where we could investigate what was going on at that time. Right now, that of course has changed. We've been able to go into the genome and explore, and what turns out is, that there are a range of strange anomalies at that point, and I consider them to be fingerprints of engineering by an advanced intelligence. So that's fundamental.
Well, what are those anomalies, right? So pretty much, just to summarize, kind of where you come out on this is there is pretty well accepted and well verified science that there was a change in skull size, and there's kind of this inflection point at one point in history. What now is starting to come out is it wasn't just the skull size change, but there was also change in the genetic code of Homo sapiens that change, I think you are in the camp of saying that is less evolutionary, and it was likely that there was some external force that acted upon that change or created that change. Is that accurate?
Yeah, it is. And one important thing to say here is that there's a number of leading academics. Again, I don't want to say that it's just me coming up with this on my own, right? Because you've got leading academics, for example, Professor Paul Davies, who is considered to be the man that humanity will turn to, if we identify the presence of an extraterrestrial intelligence, right? So, he's a leading astrophysicist, he's an astrobiologist, a mathematician, an all-round great thinker. And he proposes the idea that, alongside SETI research involving radio waves or looking at exoplanets, that we could look at the genome and see whether or not there's been a modification in prehistory which may have been carried out by a visiting intelligence, and that this could be a signature, a message in a bottle left for when a intelligence, arises on this planet. So, and this is supported by quite a number of very intelligent people in the world of science, right? So this is not some woo-woo strange idea. And in fact, I managed to get a question across to Seth Shostak at the SETI Institute, right, and asking whether he felt that this was valid research. And it was on a recent podcast. He was talking to a guy whose name's gone on my mind now, but anyway, he actually clarifies that yes, he agrees this is legitimate research and it probably should be done, but that he feels it's probably a waste of time, that we won't find anything. But mentions though that it would only take a couple of weeks to do this. Bear in mind how long has it took to not find radio waves so far, right? Decades, and that it will probably go on indefinitely without finding radio waves, with millions of dollars going into that. And yet these guys are telling us we can do a simple search of the genetic data that we already have. It might take a couple of weeks, and we could potentially find a confirmation of extraterrestrial visitation. Now, doesn't it strike you straight away? Is that something worth doing?
Well, here's the thought process is, again, it goes back to, and why I wanted to start the conversation off with, I am of the belief that science should encourage experimentation and that there should be no sacred cows, right? And the ability to expand our minds into various possibilities and then go put them through scientific rigor is really important. Right. It's kind of a belief that, a lot of innovation happens from people who are not from an industry. Right. It's because it takes to think outside the box to actually get breakthroughs. And so when I think about kind of, the work that you're doing, I want to really kind of push deep on, this inflection point in the genetic code. What are the anomalies that you've identified or others have identified that lend itself to say, look, there just is an inflection point. There is a change in the genetic code at some point in history. How long ago are we talking about, and what are those anomalies?
Sure. I mean, the key ones relate to, again, I'm going to preface this a bit for people that aren't familiar. When it's asked, if an extraterrestrial intelligence was wanting to modify us in a way that could be detected or was modified, and as a happenstance, it could be detected. The changes would have to be in areas that are highly conserved and really in the non-coding DNA. Now, the reason for this is highly conserved means essentially very rarely changing. That these are very important areas of code. Like, let's say the area that means you have a lung, right? Something like if you don't have your lungs, you're not going to do well. So highly conserved code stays very stable. So that's why they say that, look, if there was a signature, we would expect it to be found in those regions. Now, that's really important because that's where we find a whole load of these anomalies is actually in the most highly conserved regions of non-coding DNA, right? And this is that's crucial. But what we find is, for a start, I'll give you a couple. There's these what's called HARs, and the name themselves is a giveaway. They're human accelerated regions, right? Strips of code that seem to have undergone anomalous acceleration of changes, right, in the short times that there shouldn't be any change. I'll give you a more specific example. We have something called HAR1, the first one of these that was detected. Now, they contrasted a 118 DNA letter long piece of code across chickens, chimpanzees, and humans. Now, between the chickens and the chimpanzees, there was a 2-letter difference. So they realized that every 150 million years, you get one successful mutation in this area. Okay, so unbelievably stable. Very important. If anything changes, usually the organism dies. Right. So then they thought, well, contrast that chimps against humans, who roughly 5-6 million years or so of divergence, right? They expected there to be no difference by these odds of 150 million years per letter. But what they found instead was 18 letters had changed, right? So their minds were immediately blown, because there was just no explanation for that level of change. And so when they ran the computation systems, so they actually software designed to compute this, they came up with it being essentially a 0% chance of this having occurred by any understood evolutionary mechanisms, right? So in other words, they've got nothing, right? And then they're not offering any explanation for this. They've now found several hundred of these, and the ones they understand seem to be to do with fetal development, particularly fetal development relating to the human brain, which is, again, this anomalous organ that no other primate has a brain structure anything like ours. And in fact, most of the differences between us and other primates are in genes to do with the brain, right? And on top of that, we find a load of other anomalies. Some of these are in HARs are not really in genes. Okay, they're in what's called areas for control genetic expression, right? So they will change the function of a gene or turn it on or off. But we also have genes that are anomalous. There's a strip of code from one gene which has been described as having looked as though it was snipped out of a longer gene, copied, and then put back in. That sounds awfully like CRISPR type technologies, right? And then there's a second one of these where they said another brain gene, which they said it appears fully formed suddenly out of non-coding DNA, as though someone's just created the gene for one of the important areas. I think it's for the neocortex, folds in the brain, that you've got this gene just appears, right, out of non-coding material and does this incredible function for our brain. And so you've got those, and then you've got the fusion of chromosome 2, which occurs, again, 780,000 years ago, this time when these rapid brain changes going on, as we've mentioned. And this one fuses on an active gene, which is to do with the brain, the reproductive system, and the immune system. Again, key areas that you might want to get at if you're working on the genome. And that coincides with what was assumed to be huge benefits, because we know that there's a total replacement that goes underway of all the hominins on Earth, right? That before we had all of that 48, as we understand it, all primates had 48 chromosomes, right? All humans today have 46, unless you have a genetic illness, a condition that's arisen from either a fusion or a replication. And this is a total replacement. So we wouldn't expect this. We'd expect to have, say, a small, if it was a natural mutation, right, which would probably usually be neutral or usually negative, then you would expect there to be a small subgroup of people that have 46 chromosomes, and the greater group to still have 48, right? That's logic. So the way to explain this, they think, is you have to have a small group of people that all develop this in short succession, so they become an insular, isolated breeding population, and it has to give them incredible benefits for it to persist and not to go back into the background, and for it to become so widespread, right, that everyone on Earth ends up with this, suggests that the changes were so incredibly beneficial that nobody else could compete with those that had this change, right? So that is another one of these glaring anomalies. So how did that happen? Today, we might look at that and say, well, hey, with CRISPR gene drives, which is a cutting-edge technology that's just coming in now, you can actually modify, right, the chromosome in such a way that when two individuals interbreed, so you have your male and female, usually you get a copy of information from each. Using gene drives, you can make it so that your new modified information overwrites that of the other parent. Yeah. So no matter who the human mixes with, if it's another hominin, Homo erectus, for example, right, the child will be like the modified parent, not a mixture of the two. Right? And that also is another way you can eradicate species. They're using it for mosquitoes, right? So you can use that to ensure that everyone that's born from those unions will be the new kind of creature, right? So that's, again, it's fascinating to see that that's something we're doing now, and that would easily explain this total replacement, is that a use of a kind of a CRISPR plus gene drives technology, right? So we have these anomalies, glaring anomalies there that are clustering in on this period 780,000 years ago, when the brain suddenly goes into overdrive, and we have all these anomalies, and it's just, and as I say, they're in the regions where the leading experts tell us that we should look if we were to if we were to find extraterrestrial modifications. Those are the areas we'd look to. And like leading academics are telling us, we should look and see if it's there. So all of that's happening, and yet somehow that's being left to me, instead of a leading academic, which is the strangest part of it all, really.
Skirt, skirt. Want to know who has the best URL? Crypto.com. That's right, Crypto.com. They're a crypto platform with one goal: mass adoption. That's why we're all here. We're trying to get crypto in every wallet. Crypto.com is helping people do that through buying, earning, lending, and card payment. Everything you could want at Crypto.com. Go help your boy out. Tell him Pomp sent you. Download the app or visit Crypto.com. Pomp's got you, always. Ever wanted to get into mining and didn't know how? Don't worry, your boy Pomp's got you. Everybody got some electricity and Wi-Fi. All you got to do is go to coinmine.com. You buy a coin mine. It's like an Xbox or a PlayStation that helps you turn your electricity into Bitcoin. That's right. You purchase it. It shows up at your doorstep. You pull it out of the box. You plug it in, connect to your Wi-Fi. 5 minutes or less, you're mining Bitcoin. All you have to do is control it from the mobile app they provide, and then you receive over-the-air updates that add new coins and new features on a consistent basis. Kind of like how Tesla does over-the-air updates and updates the car software. Just you're updating your coin mine. Consumer mining made easy. That's right. Go to coinmine.com, tell them Pomp sent you, and thank me later.
One more word from our sponsor, BlockFi. Their new interest account allows you to securely deposit your Bitcoin or Ether at BlockFi and receive 6% annual interest paid monthly in cryptocurrency. This rate actually compounds, so you receive a 6.2% APY, which is very attractive given the alternatives. So you can actually take your Bitcoin, you can deposit it with BlockFi, and get paid an interest rate of 6% in return. Go check out blockfi.com/pomp. Again, blockfi.com/pomp to sign up and start earning interest on your crypto today.
And I guess the big thing here is that there's two buckets to this, right? The first bucket is identifying the anomalies, which it seems like there is enough people who recognize and identify them, right? So it's harder to argue that the anomalies don't exist. The second bucket is how did they get there? Right, or what was the force that, or kind of the reason? And now this is where I think you get much less consensus, much less confidence, and because of that uncertainty in answer, you end up getting a wide variety. Everything from natural evolution to something that looks like CRISPR to something that literally could have been sprayed on people. I mean, there's all kinds of wild theories there. I guess my question to you is, you have a very specific kind of idea around what happened. What is the evidence that you've either located or the work that you've done to specifically identify that specific theory as to what drove these anomalies?
Sure. I mean, it zones me in on that date as well, 780,000, which I don't think you find in any other models, to be honest. Nobody else seems to give you a specific point, which is important, but the reason why I can do that is not only do we now have these anomalies, but I was already looking at that period because I was sort of following some clues in a set of mythology, but information that's come out of Aboriginal Australian stories, mythology, from which allegedly, and again, this is allegedly, that they have an artifact or artifacts that they call a chiringa, right, which is a small, supposedly stone-like object with some symbols on it, which they consider to be the most sacred objects, right, and that this can, in some way, transfer information, and that they would get historical information from this object. Now, in the stories that they share, their mythologies, whatever you want to call it, there is evidence that there was a visitation. They claim that there was beings that came from the Pleiades, is one of the areas specifically mentioned. There's descriptions of what sound like wormholes, like some kind of great tree trunk that connects us to this place, or a tunnel, or a rope, right? There was all sorts of things in there that were fascinating to me. And on top of that, there's descriptions of a craft that comes here, right? And particularly a crystalline craft. Now, you can easily start to think, okay, it's just stories. Like, as you said, there's lots of mythologies, Anunnaki, the Bible. So what's different here? Well, I thought there was enough in there that was specific that I thought, well, I can test this. There's a description of this very large crystalline craft. It's basically a living craft, right? To me, I'm thinking self-aware AI, because on the cutting edge of the AI world, we know that the theorists are telling us they think in the future there will be vast silicon networks inhabited by self-aware AI, or even uploading human consciousness into these silicon networks, right? That we know that's essentially where the arrow is pointing. Now, being up to date with some of that and understanding that, when I hear about a living crystalline object, I'm straight thinking, hang on a minute, this, it might sound to some people like woo-woo, big crystals. But if you understand that, you realize, hang on a minute, no, this is the kind of thing we should expect to see from an advanced extraterrestrial civilization, right? So then there's specific descriptions of this thing being in orbit, breaking up, material raining down, and enough there that I'm thinking, well, if this is real, I can check it in the geological papers, and see if there's anything that matches this. Now, a part of me was thinking, there's no way that that's going to be that, even if it's real. It's so long ago, right, 780,000 years ago, that I'm not confident it would still exist. So I went through, and it turns out that there's a 100-year-long mystery in science about a material called australite tektite. Now, australite tektite is essentially it's a 75% silica mixture with other aluminium and a wide range of other chemicals, magnesium. So I think there's about a dozen or more chemicals in there. But anyway, it's particularly anomalous in that if you look at a map, I know I sent you across a map of this distribution field for it. It's enormous, right? The material covers between 10 to 30% of the Earth's surface, which when a normal, say, an impact, right? When we get an impact, even a fairly large one, the material usually is in a fairly, fairly tight cluster. Yeah, we don't tend to have it that widespread. In fact, there's nothing comparable, right? But this material is widespread. The other thing about it, it comes in a unique form, which is called a button tektite. Now, some of the material, in other words, came from space to form this particular shape. It looks like a nose cone of a rocket. So NASA, they looked at this because they understood that this had to have been shaped by the aerodynamic forces of material passing through the atmosphere from space. Okay, they also worked out that the source body was an object at least a kilometer in diameter that was in orbit around our planet when it broke up, and that the material carried on a horizontal plane to the Earth, essentially in a decaying orbit, and came through a shallow angle, had secondary melting, which formed these button shapes, right? But they initially was in a sphere, and spheres of liquid form in space. So it was liquid in space, in the vacuum. In fact, there's bubbles of hard vacuum in the material, so we know that it formed in space, and then it melted on its way through. And we have this material right across from the southern tip of Australia, in fact, Antarctica, all the way up to southern China and Laos. This enormous distribution field. So seeing that and understanding that, hang on a minute, this is the exact signature for the kind of event that's being described, and then finding the date on it is 780,000 years ago, right, which is bang on when these changes are happening, right, in the brain and the genome, that we've got this, what matches to this object that they're talking about that's come through a wormhole and, a living ship, right? So I'm thinking, hang on a second, this is crazy, because there's not a natural solution to this, because asteroids, comets and stuff, we understand what they're made of, right? We've done pretty extensive work on that. They do not mesh with the chemical composition of this material. That's the first thing. For example, asteroids, you can have silica up to around 60%. You don't ever get it up to 75% silica. Also, comets and asteroids of the size that we're talking about here cannot be pulled into orbit by the Earth's gravity, right? In fact, they'd be accelerated past us, right? As if they came that close, they would essentially be accelerated past, or they crash into us. Yeah, they don't end up in orbit. So what kind of comet or asteroid can slow down, park itself in orbit, right? So this is a problem. NASA don't talk about that. They talk about what the material's made of, how it rained down. Nobody seems to tackle the glaring anomaly that this thing is parked in orbit. Yeah, so that's an absolute mesh. We've got these legends claim. Now we have that, and then there is the second part, which we touched on earlier, which is that amongst the information is a claim of a multi-directional bombardment of asteroids around the same time, 5 years later, in fact, it's quite specific, that there is this other bombardment. And like, I'm thinking there's no way, that this has happened because I've never heard of it. I think I'm fairly well versed in ancient events, particularly big cataclysms. It's a passion of mine. I like cataclysms in history. Never heard of it. So I went searching for that to see if there was any evidence of that part of this claim. And it turns out that in 2015, a team of geologists from a university in Germany, they found this multi-directional bombardment that we discussed earlier, right? So it's a very recent discovery. Certainly nobody should have known about it, in ancient times in Australia among the Aboriginals. Right? It's a 2015 discovery. And that these things were, some of them enormous, as the one we talked about in Antarctica, right? Leaving a crater 200 miles by 200 miles, absolutely enormous. That this is also part of the claim, that this event happens around the same time. Now, what I didn't know as well is that supposedly these impacts may have actually caused the magnetic reversal. And now this is being looked at the moment, that they think these huge impacts are what initiated the sudden field reversal and are probably why we haven't seen one since, that this destabilized the normal cycle of the Earth's field. And so we're getting a cluster of mega events, right on that moment, which also happen to fit with this narrative that's coming out of an Aboriginal Australian, cultural setting, and that they relate to an object which can communicate information. Now, what is that object? I would posit that it's a Bracewell probe.
And so one of the reasons why I wanted to have this conversation was you had said to me that there was essentially this identification or detection, right, and of an alien technosignature in the form of an extraterrestrial post-biological artificial intelligence craft. Mm-hmm. That's essentially what you're describing right now, right? Is that the theory that you have created here and are in the process of testing is that what we see in those early stories or art, etc., end up coinciding with scientific revelations or studies around the breaking up of some material that ends up striking the Earth, etc. Your claim is it's unlikely to be more of a meteor shower as much as it is a certain type of material that we previously had not seen on Earth before, right? So it's something that came not from Earth, but how do you make the connection from that material to, kind of the extraterrestrial, post-biological, artificial intelligence craft? Like, what does that mean, and how do you make that connection from the material to that theory?
Sure. I mean, because we would expect it to be a highly silica material, and I'd say this is way beyond the percentage of silica that's known in asteroids, meteorites, or comets. So irrespective of the other compound, I mean, there's other chemicals in there that make it unlike asteroids or comets, okay? But the signature for me is this extraordinarily high level of silica, because if we have like a quartz crystal being the main component of a living AI craft, then we would expect melted silica to be, the highest percentage of the debris from the destruction of a craft like that. And that's what we find in it. So it absolutely parallels what we should expect if we were to be visited by a craft like that. I mean, we're fortunate that it's destroyed in orbit for whatever exact reasons. But if we hadn't been, we'd have no evidence, obviously. But the second thing is that the fact that this can park itself. Yeah. Now, I've looked at the astronomy and physics information on this, and it is stated that these objects cannot end up in orbit. And I just want to reiterate that to people, that if they want to posit a natural solution for this, then you have to explain the physics, right? You have to say, how can this vast object park itself in orbit? Yeah, and then you have to deal with the fact that there's several papers pointing to an extrasolar origin for this material due to detection of the effects of cosmic radiation on it, and also some of the isotopic values in it that suggest it has come from outside of our solar system, which again is important. So we have an object from beyond our solar system that is unusually high in silica and that can stop and move into an orbit, right? And that happens to coincide with several other huge anomalous events, right? Including this, a few years later, this bombardment, which almost resets the Earth, and then strange changes in the genome of early hominins, right? And we have this connecting to an Aboriginal story of an object, which sounds like a Bracewell probe, which if people are familiar with Bracewell probes, essentially it's another self-aware AI, but on a smaller scale, an object that can be left on a planet. There's something called a sentinel probe that they can record, they can maybe do other functions, but they can record and they can also interact at some point. Now, the theory by the scientist Bracewell was that these could even be used to make contact with a civilization. If you send them out into space, you leave the hard AI on board. They have von Neumann self-repair functions and maybe even self-replication functions. So you can have these things spreading out across the cosmos, arriving on planets, or even hiding in orbit and orbiting around planets, watching them, or being left, and that you just leave them as a technology that's indistinguishable from background material. So let's say you hide it, it looks like a rock. Yeah, now, it's always been said that a truly advanced technology would probably be unrecognizable to us. And that's understood in these levels of theoretical sciences on these subjects. So, that we wouldn't necessarily know what AI tech looks like. So if you imagine a group of ancient Aboriginal people encounter a Bracewell probe, not knowing what it is, and that this thing is able to communicate information, I would suggest through a voice-to-skull type technology, which we have now in MIT and places, they're working on these, and they can transfer information, starts telling them about how it's got here, the background, the story, and they decide it's we might think of it as a sacred artifact, a holy artifact. It's put into the most, the holy of holies. You're not even supposed to look on these things, right? Only the highest initiated people are meant to even go near the thing, right? That's the cultural understanding, particularly the Arenti people and another group that also have this belief, and that this object seems to then be producing valid information which can be verified. That's the key bit. I haven't seen it. I haven't gone and touched it. So you can say, okay, maybe it's not there. I don't know. But the fact is, the information that I've looked at and I've used led me to these astonishing discoveries that I never would have existed. I wouldn't even be looking for this if it wasn't for that. And it turns out you have, at 780,000 years ago, all of these events, this strange object in orbit, the changes in the genome, the bombardment, and the magnetic reversal, all on 780,000 years ago. And it's almost extraordinary that we don't have that as a well-known discussion, like the dinosaur subject. The fact is, there was mega events going on, and they're not well known. It's really bizarre. And like I said, even as a theorist in these subjects, I hadn't heard of any of these until I started doing this research. It was really extraordinary.
Yeah, and I think, as I look at this, right, you spent many, many more hours than me on this, but the way that I break down kind of the work you've done so far is you have taken pretty well-established, accepted scientific fact around some of the materials, some of the bombardments, etc. And then you have also used what I'll consider more theoretical constructs, right? So whether it's somebody else's, right, in terms of the methodology that other people presented, or things that you have, and where you've come to a conclusion is those things, when overlaid on each other, all intersect with at the same time period as a number of very interesting anomalies that can, again, be identified and are fairly well accepted from a scientific standpoint. I guess the big question that I have for you, right, is because when you combine well-accepted fact that has been established through scientific rigor with things that are more theoretical, you introduce the idea of like a confidence level, right? Because the theoretical component of this ends up being harder to back up with supporting evidence, because you're still putting them through the scientific rigor. What would you put the confidence level you have in terms of kind of this theory being accurate and in the future being able to prove some of it to a greater extent than we are today?
Well, look, I'm happy for people to look at the mythology part of it, if you want, as being simply something that got me interested in the topic. Now, whether it's real, whether there's really this artifact and it can do all this, I can't say, because again, to be objective, I didn't see the object, I didn't have an experience with it, right? So you could say, okay, well, even if you discount that, you're still left with these genuine, as you say, rigorously scientifically tested anomalies, which are clustering together, which is an anomaly on an anomaly, right? Because when you get those kind of things happening at the same point in time, again, that's a red flag for something strange is going on. And then on top of that, you can scientifically evaluate things like, how would why is this object made of materials that aren't typical, right, for other bodies in our solar system? What causes it to stop in orbit? These are testable, right? Same as with the genetic data. Again, that's testable, because you can, if you infer that there's been possible modification, now what would be required is geneticists to spend some time focusing particularly on changes that happened around 780,000 years ago, and on those anomalies, the HARs, and also on the fusion event. Right, these are testable. And on top of that, not only testable, if you really think about it, I mean, for anyone out there who's in the genetics field, right, finding the fingerprints of master geneticists, right, and just as we're going into the genetic revolution with CRISPR, if we can find the fingerprints of master geneticists who could make humans out of these early hominins, right, that's got to be invaluable information. If I was in the genetics field, I would want to hone in and see what did they do, because we're about to open Pandora's box, right? We all know that. Yeah, we're going to start modifying babies and stuff. We're going to start creating new humans. Wouldn't it be nice to have a starter in that from an extraterrestrial intelligence that knew what the heck it was doing and was able to go in there and almost play us like a piano at the code level, right? Like these master code breakers, they went in, changed humans. If that is valid, yeah, and if the evidence is really pointing to that, bear in mind there's a 0% chance of these changes by known evolutionary means. 0 so far. No other solutions except for an intelligence being involved. Yeah. That if we can go in and find what they did and understand it, maybe we can evade the horrors of experimenting on humans with all these technologies and know what the hell we're doing, right? And actually fix problems instead of create problems. So I think there's a financial and ethical reasons for why we might want to check this, really important reasons, and that we have valid science there. We already have these HARs identified. We have the knowledge on chromosome 2. It's there. Right, I'm not a geneticist. I cannot go to the lengths I would like, right, to validate this. What I would like is the engagement of people who are capable of now going in there and saying, hey, yeah, actually, you know what? This does look like the signature of, what we would do if we had the know-how. This is how we would change a human, right? Because that's something that there's people who are capable of doing. And again, with this object, astronomers, physicists should be able to look again at that ostrich-like material and say, hey, could this be the composition of an advanced craft? Because surely our space scientists, right, and our our designers and stuff, wouldn't you want to know what an extraterrestrial race builds its ship out of, right? So again, these are huge drivers that if people take this seriously and look at it, the potential benefits are enormous versus the costs. I mean, we already have most of the data there, so the costs are minimal. The payout could be enormous, beyond imagining.
And so what is your thoughts on CRISPR technology kind of as we go forward? Is this something that you're in support of and you think should be encouraged and experimented with? Or are you more on the side of, hey, this is very dangerous and we should be incredibly cautious and probably shouldn't push the pace of innovation there?
It's definitely dangerous. I mean, there's no doubt it's dangerous. But I mean, it's also inevitable. I don't think any controls will ever stop it completely. And we've already seen that, a scientist in China started changing some babies. He didn't have permission. He just did it, right? I think there's been recently some testing done with merging chimps and human DNA and stuff, right? So this stuff's going to happen, whether I agree with it or not. But I actually would support it in a way. I think particularly if we want to be a cosmic civilization, if we want to go out into space, right, we are going to have to use these technologies. I don't believe it's possible for a Homo sapiens to go out and colonize space. We suffer with incalculable conditions. Even just going up and being in the space station, right? You start to basically degrade away here. And then we have links with not only the Earth's field, but the Earth's rhythms, which means that if you were to relocate to Mars, it's not clear that we could even reproduce there. our fertility and stuff is maybe we won't actually be able to have children on another planet. How do you colonize worlds, right? If your bones degrade, you start getting weird illnesses, you can't have children. At some point, we have to look and say, look, if you want to go into space, it's not just about the technology you take with you. It has to be the organism itself has to be changed and has to be adapted for the environments it's going into. So I support that as long as people are happy to have therapies done to them to be an astronaut. Now, I don't know whether I'd say it's right to experiment on a fetus and say we're going to engineer the next generation of space people, but without asking them, we're just going to change the fetus's genome. That I wouldn't agree with. Obviously, that's very very much an ethical issue. But if there are genetic therapies which an adult can say, well, okay, I'm willing to have that done. I want to go into space, then yeah, I think that is the only way that we are going to explore space.
What is the issue with kind of the human as an organism in space? Is it like a radiation thing, or what exactly is causing that degradation of the human organism when it?
Gravity, one of the major. I mean, we're unlikely to end up in an environment with our exact the exact strength of gravity that we have here. That's a major issue for us. We are well acclimatized to the breathing environment. I mean, let's say that you find a planet that has a different balance of gases, right? But it's not completely poisonous, but you would struggle to breathe. And the gravity was maybe 50%, right? And then it's time moving around the star is different, and the day is a different length. Like, we have a lot of problems with that. All of our natural rhythms will be thrown out. Yeah, our breathing is going to be a problem. So say maybe reproduction is a problem. We're going to have all of these issues, right? Your bone basically you lose bone density. So you have all of these problems. If you can modify humans for that environment, then you can maybe overcome that. We can change at a fundamental level. Our requirements for breathing, for our reproductive system. There's all sorts of things that we can potentially do if we have a thorough understanding of the DNA code and of how the essential parts of the genome, particularly these highly conserved regions. Because if you start playing with highly conserved regions, if you bear in mind that through natural mechanisms, it takes 150 million years for one successful mutation, like in some of these areas, right? Obviously, they're very dangerous areas to just play with, right? If you don't know what you're doing, you're really going to kill almost every experimental fetus, right? So, but if we can understand those areas, you can really change almost anything about us. You don't need. That's why hybrid humans in my work. I don't necessarily need splicing loads of alien material. You can hybridize with other species. Like you can put in some genes from a fungus, some genes from a cow, whatever. Yes, some degree of that. But I think mainly what we're going to be looking at is modifying the code at a very fundamental level and not necessarily having to hybridize too much, although that will be part of the story. Yes, we're going to take things that we think are beneficial. You might take a gene from a squid because it gives you a benefit to live on Mars, right? That for some reason it gives you a benefit. So yeah, we'll put that in. But a lot of this, I think, is modifying the code. I broadly support it as long as it's, again, done in an ethical setting. But I mean, the ethics are complex because you're not just changing yourself. If you have children, of course, you have decided for your children that they will be Homo sapiens 2.0, right? That they don't get a say in that, even though you're not modifying the fetus. If you're modifying the parents and they have offspring, the offspring have had that modification, like it or not, right? So obviously the ethics of these processes are inordinately complex, but their nature changes us without asking. So
Yeah, and look, and part of this, I think, is there's two components in my mind. One is just the end state, right? Eventually, we will be genetically modified. Kind of these weird combinations of science, technology, and humans, right? And there's some very easy, uncontroversial things like, hey, if we could prevent disease, or we could prevent some sort of genetic issues, that would probably be a positive thing, right? Especially if we could do it with no side effects. Mm-hmm. But then there are kind of much larger arguments around just, hey, humans want to run faster, jump higher, be smarter, kind of the augmentation. I think the controversy is really how do we get to that end game, right? And so if you look at
China versus the U.S., I'm probably of the mindset that China has a significant advantage when it comes to biotechnology, the biohacking, the CRISPR technology, et cetera. Because frankly, they're just willing to do things that here in the United States we're either one, unwilling to do, or two, we think is unethical, and they have no problem with it. Right? It's a cultural difference. And so, again, it goes back to the idea that the group that has the ability to provide resources to something, to have their smartest people working on it, and to encourage experimentation, they're just likely, it's the probability that they're going to make faster progress because they're spending more time on it.
Yeah, absolutely. And I think that we probably will see China in some respects leading this. And I think, again, I don't want to get too much into the way different cultures think, but we know that the Chinese culture historically is about kind of what's good for China, is thinking within China's boundaries, but obviously using resources and relationships to increase that, and obviously tech, sometimes borrowing ideas and whatnot. Whereas the US, Europe and stuff, we tend to have this more about this global idea that, we're making this global community, and the way we think is very different. I think China's more insulationist in that respect. They're not really, although people say they're looking like they're going to invade us. I don't think so. If you look at China, what they can say more about is what's good for China, and China keeping its own culture and its own ways distinct, right? Whereas we like this idea of globalism and they're completely different. I feel that within that, the Chinese mindset is very different, and that they are willing to push these boundaries. And we know that historically, even that they were ahead of us in science. If you go back centuries ago, they gave us gunpowder and stuff. They had scientific revolutions that were unparalleled, right, in the world beyond at the times they occurred, right? Again, like the Arab world at one point, again, was well ahead, in the sciences with medicine. But they historically, I think that the culture favors that kind of progressive thinking in some ways. In other ways, not. I mean, there's ways that, where we wouldn't probably say, oh, that's really progressive in China. But in the tech and in this, in the biohacking and stuff, I think that, they're going to really leap ahead. And clearly, again, in your areas, but obviously we're seeing that in blockchain tech and everything. The Chinese really, I see them ending up with some of these kind of super people probably ahead of us. And I think a lot of these millionaires in China are looking to, and also that the idea that, that having your children thought in a different way as well. The idea, that we know historically that, the son had to be the dragon guy, and all the others, that they're kind of thinking about making the best children, and the one-child policy, which led to, that we had to have a boy because a boy is better for various purposes. So that kind of thinking as well, which we wouldn't be so familiar with in the West, right? Which leads to the idea that, there's also this. I think there is that focus that now they want to make that perfect child, that it's going to be the best, the strongest, the fittest, which again fits with the cultural background. So I won't be surprised if we get left behind in that. I mean, as I say, they already got that experiment where the chimp and the human genes are mixed. That was in China, because the guy is actually a US scientist, I think, and he couldn't do it in the US because of the regulations. So he just moved the experiment to China. And obviously we had the other experiment I mentioned where CRISPR was used to modify a couple of babies there. So it's already happening, right? So it's sort of inevitable that unless there's a change in the mind state in the US and in Europe, that we will be left behind by the Chinese, and that they will have genetically enhanced people, So what do we do with that? I mean, I guess we have to in some way. I don't know. What is your thought on that? Do we go with it, or do we stay conservative?
Look, I tend to think that there's a middle ground, right? So it doesn't have to be binary. And what it is you basically create opt-in programs, right? There's a lot of people who would be more than willing to opt in exchange for whether it is payment, whether it is the potential to solve a problem they have, right? Whether it is they have a disease or something like that, and they're willing to do more experimental treatments, or even there's plenty of people who literally would be willing to take the risk because they would like to run faster, jump higher, or be smarter, right? And kind of the augmentation stuff. But I'm more of the belief that every human individual should have free choice and should be allowed to kind of take the risks that they want, as long as they're educated on it, right? So I don't think that it's a thing where you can just blindly, one day wake up and say, hey, I want to, get CRISPR done. But I do think that if there was some sort of educational course or something that somebody went through and they were very, blatantly and simply told what the potential upsides are and what the potential risks were, and then you make a decision for themselves, right? And kind of the government should stay out of their lives, frankly.
Well, I agree. Look, if we're okay with the idea of sending people one way to Mars, right, which is something that there's been obviously a lot of volunteers have said that they would go on a one-way trip to Mars, with the sort of Mars One and all this, right? And obviously SpaceX and other people are going to try it, Look, we know there's a huge chance that first mission is a disaster, but we would allow people to go into that disaster, right? Because it's in the name progression and they want to do it. As you say, they're choosing to go. Now, if we're happy to send people on what is probably a disastrous doomed mission to Mars, the first manned mission, maybe it's successful, but I think most of us would be conservative in that, thinking that the first time, probably not good. But what if we could say to those people, well, hey, look, obviously you're willing to throw your lives at this. We can also offer you gene therapies that will give you a better chance, at least, of surviving on Mars. Now, isn't that the right thing to do? I think that's the right thing to do, because if they're going to be probably stuck there, and you know that they're going to struggle with the gravity, the atmosphere, is it any more radical to offer them these changes than it is to send them to live on an alien planet, without any real way of surviving there beyond being in a bubble, which could fail at any time? I think that, again, we start going to, if you're willing to throw people into what looks like disasters, why not let them have the choices to do other things paralleled to that, which I think that, these China technology are parallel, no more risky or crazy than sending people one way to Mars.
Absolutely. And look, we could talk about this stuff forever. One of the things I want to make sure we talk about before we go is, a lot of what we're talking about here, it's not lost on me and probably not lost on you that either one, it's unpopular. Two, there's some people who just kind of write it all off and say that's just crazy talk. And then three is there's actually a lot of establishment or incumbent organizations, scientists, et cetera, that will go to great lengths to prevent the spread of the information because it potentially threatens their position of power, importance, or work. You've actually had a number of occasions, certain levels of censorship that you've dealt with. I think recently there was a situation where you were cited in an article, and then all of a sudden, it was kind of deleted, and it was, really that publication saying, "Hey, he's not a professional anthropologist, right? You can't use work." Maybe just talk a little bit about your experiences with trying to share these ideas and what you've run into, both positive, from the supporting side, and then also negative from the obstacle side.
Sure. I mean, I've said I have some quiet supporters. I do talk to some scientists who are helpful and they give me feedback on things that I do, but mostly in quiet, because again, it's detrimental to them to be publicly associated with me, right? Because I'm dealing with radical ideas or ideas that aren't in the consensus. So I understand that. It's sad, but I understand that. I understand why they don't want to be publicly associated with me in my work, right? Which again, but that's a cultural problem. And then we have, of course, the media, which is a big issue, because without getting this kind of information out into the media for dissemination, then there's no pressure for scientists to look at it, because then they go, well, most of them won't even hear of it for a start, Obviously, the way the framework works, usually discoveries are supposed to come from a university or a foundation. A press release goes to the media. Then they publish an article, it may get popular, in which case it brings more support to that research, etc. If you're on the outside of that, me contacting journalists usually results in one of two things. Either total silence, probably goes into the spam box, whatever, or a reply of, not really interested kind of thing, because it's not what they're expecting, right? They're thinking, oh, it's some crank or whatever, that they don't get as far as to even know if you have real evidence, right? You'll never get to that because you're not PhD so-and-so from university such and such, right? The door closes. But the exception I had there was I had a scientist who was also a science journalist who saw the validity in my work. Now, that doesn't mean he agreed with all of the hypothesis, but he saw the validity and he saw that I was using, peer-reviewed academic sources, right? Which is sort of gold standard sources. I'm not going out and pretending that I'm doing archaeology or genetics, on my own, right? There's none of that. When you say pseudoscience, it's not pseudoscience, because if it's pseudoscience, then the sources I use are pseudosciences, which is ridiculous because most of them are leaders in their fields, right? And so this guy, he wrote an article for Forbes, and that went out, it was last December. And within a couple of hours, it'd been spiked by senior editors and deleted. and he was told that never to refer to me as a source again because that I wasn't a suitable academic source for the story. And it's like, as he said, it doesn't make any sense because obviously, if there is a criticism of the work, that's the place to have it. Is you put it in public, scientists can see it, they can clarify in the comments or with a response article, right, saying, oh, Fenton is wrong because of this, this, and this, and to have that discussion, which, is, as he said, is a legitimate process, right? You have those discussions. The fact that you're silencing that conversation is ludicrous. That's obviously censorship, right? And the fact was that they have, well, as you know, like in Forbes, there's loads of articles, right, which are opinion pieces, which are not coming from like the leader in an academic field, right? That you'll have religious conversation where people just whatever thing they believe, and that's fine. But when you're dealing with a sacred cow, as I was, because it was about out of Africa and challenging the recent out of Africa, that was no. That cannot go out there, and that was just spiked. It was so rapidly that almost my head spun. That a couple hours later, someone has just gone in there and spiked it and said, "Get that off the website." No explanation. And even a leading anthropologist said to me, like, he was baffled. He was like, "Well, they didn't even put like an apology to readers that we've deleted this article because we think it's got something wrong with it." Nothing. He said that's always like offensive to the readership because you're saying it's good enough to publish, and then someone else is coming along and saying, "Get it off there, delete it," with no explanation, right? And again, this leading anthropologist was actually baffled. He said he'd never heard of that happening to anyone, right? So think about that.
For sure. And I think that part of what you've experienced, we're seeing with, what is now coming out of the shadows with more of like the UFOs and Area 51. And it almost feels like there is more acceptance or responsibility being taken, whether it is individuals that have had these experiences and are able to verify or support those claims, or it is the U.S. government themselves, right, in releasing various videos or kind of details. What's your take on kind of these individual stories that we're hearing and kind of why now some of this stuff may be coming out and maybe becoming much more accepted and less taboo?
Yeah, I mean, it's interesting. We have this phenomenon now where the last couple of years, major media platforms are tackling subjects like, UFOs, also now possible alien materials, debris that may come from an extraterrestrial ship. Would you have thought, 3-4 years ago that you'd be seeing articles in like the New York Times that were talking about UFOs and, major media platforms talking about alien debris? I mean, it's quite a sea change, isn't it? I mean, it's, but
even the Harvard professor who says, the UFO that came into the solar system and then kind of left, all of this stuff is it is getting what I would consider valid media attention and coverage, and I think it's driven partly by curiosity and partly by the fact that it's hard to ignore at this point.
It is, and right, and the fact that we've got the head of the Harvard astronomy saying that this Oumuamua object could have been a probe, an alien probe coming through our solar system. I mean, that's astonishing. And again, some people saying that he was doing that just for media attention, but as he pointed out, he put it into, some obscure science paper, and that he hadn't even put it into the public. It was a journalist or someone stumbled on it and realized that, that this would make a good story. But, it was a serious science paper. He wasn't trying to get any attention or anything, right? He noticed that it had anomalous characteristics, that, it was unusually reflective. It seemed to be spinning in a certain way, which again suggested it was unusual. It had this red coloring. It was covered in a lot of what they think is a metallic kind of debris or something. And then it accelerated as it moved out of our solar system. And another thing that I want to highlight there, because I find Oumuamua really fascinating, what I suspect, again, could be that it's some kind of panspermia machine. And the reason why I say that is because when it came through the solar system, it doesn't just pass by Jupiter or something, right? What happens is it entered our solar system basically between the orbits of Mars and Earth, and it crossed the plane of our solar system between these two planets, the orbits of these two planets. Now, that's awfully coincidental because Mars and Earth are the only two planets in our solar system that are quite obviously capable of supporting life. right? That they have water, they have, a soil, which we now say the Martian soil could grow things in it. We think there's probably bacteria. In fact, the news came out, didn't it, recently, that they're admitting that decades ago there was the signature for life on Mars. We now have multiple signatures for life. We have the methane emissions. We know there's liquid water, there's frozen water. There's this, as I say, there's past soil sampling with what seems to be life. There's pictures of what look like lichens on rocks. Basically, you've got what look like mushrooms growing on rocks. Right, so isn't it funny that this object just happens to pass between the only two planets in our solar system that look like they can support life? So if you were sensing for life, that's basically where you'd want your probe to go. But also if you were distributing life, if this is something that's launching out spores, bacterial spores or something, again, we may even have these raining down on us from the machine. But either way, he was willing to point out that this had characteristics that suggested it could be an extraterrestrial technology passing through our solar system. And that's astonishing to see someone of that caliber saying that. And he also goes on to say as well, which is a key quote I kind of use, about says that that when we're although that we should have evidence, I'm paraphrasing, says although we should always have evidence of things, if we find an anomaly, we should recognize the anomaly. Right? And otherwise, how do you progress anything, right? Because unless you're going to say, look, this is super weird, let's throw some science at it, right? Let's work out what this is. If you just say, well, it's weird, now everyone look the other way until it's gone, pretend it's not there, right? But what the heck is that? So that's what we've been doing with anomalies, right, for centuries. We've been doing the let's pretend they're not there. And I think that what we're seeing now is a sea change in that it's like, well, look, there's all these anomalies, there's these, what people call UFOs, there's strange things flying through our solar system, there's, abnormalities in the genome, there's all these anomalies. Hey, why don't we turn and face them, do some really good science and find out what the heck they all are, whether it's psychic powers, I don't care, whatever it is, no matter how strange, we should throw good science at them until we can either explain them or explain them away, right? And that's how it should work. And UFOs is now finally getting that term. Like UFOs is a term I don't like to use, right? But you sort of have to, right? I'm not very interested in UFOs. I'll start by saying I'm definitely not a ufologist. I hate the term ufologist and ufology because, if you think about it, you wouldn't refer to an underwater swimming thingologist, right? But you'd have a marine biologist. Yeah, we all know what a marine biologist is. An underwater swimming thingologist is unbelievably vague and just sounds ridiculous, okay? Ufologist is the same, really. You've got an unidentified flying objectology. What the heck is that, right? And a UFO contains 95% explainable phenomena. So misidentifications of airplanes, balloons, satellites, right? So I'm not particularly interested. If someone says I saw a UFO, I think, well, it's probably a satellite, because most people don't even look up, right? So what do they really know about the things in the sky? Yeah, almost nothing, right? So what I'm interested in is where the filtering's been done. So if an organization like MUFON, the Mutual UFO Network, if they take the cases of the UFOs and they go through them, right, they get rid of all the junk, what you end up with is something like 5%, that remain, and that these are anomalous phenomena. These are basically anomalous aerial vehicles, AAVs, and anomalous aerial phenomena, AAPs. Now, that's what I'm interested in, these anomalous aerial vehicles and phenomena, okay? The 5%. I'm not interested in UFOs, I'm not a ufologist. And as you can see, I'm quite clear that it's anomalous phenomena I'm interested in. Because anomalous, that is an initial identification. So they're no longer completely unidentified, because if you can find structure or propulsion or cloaking tech or something, right, you're now starting to get an identification on it, right? It's a craft at that point, yeah? It's not just, ooh, a light in the sky, what's that? Oh, it's a UFO. If you can tell me, no, it's triangular, it was metallic, it's got a radar signature, it moves like this, right, well, okay, you've identified that it's a type of anomalous craft, right? So now I know what's it made of, where's it coming from, how does it move? Now you've got something to work with. And the same with anomalous phenomena, that if an object can just vanish or reappear, whether it's a glowing orb, which some of these things are, these glowing spheres, which seem to just disappear, change shape, right? That's anomalous. If it can disappear or it can change shape, then, okay, it's not a Chinese balloon, right? It's not a satellite, So again, I think people need to understand that the ufology, that really is such a nebulous, vague thing. And there's a reason why people laugh at you if you say, I saw a UFO. Now, if you could say to them, I saw an anomalous aerial vehicle, they'll probably stop and think, well, what's that? And ask you, why did you say that? You say, well, because it was teleporting, it was teleporting around the sky. At that point, you've got someone's attention, right? In a different way to, I saw a light and I think it was, something.
What's your take on kind of intelligent life outside of Earth? So you've got a lot more kind of study in terms of how there's been an intersection with that intelligent life and human origin and the things that we talked about. But where do you come out? Is there multiple colonizations out there of intelligent life and it looks like the movies? Is it something else? When you kind of think about the possibilities, where do you have the highest degree of confidence?
I would probably err on the side of what some of the leading theorists in the field have said, which is they suspect that the majority of truly advanced, far advanced alien civilizations will probably be post-biological, that at some point they will upload their awareness, their consciousness, their intelligence, into these vast silica networks, or that they will go extinct, leaving behind the machines they created, right? Robots, AI, whatever. So you've got two different ways in which converges, where you end up with AI, okay, and technologies that will be roving space. Also, that if you're running an advanced SETI program on an alien world and you're more advanced than us, in fact, even at our level, really you're sending out robots. We're exploring Mars with robots. We're sending out robot probes to look at meteorites and stuff, right? So you're most likely to encounter a robot, right, or an AI, and probably from multiple worlds. I think the galaxy is probably full of AI probes from different civilizations, and at this point, the galaxy is old enough that these AI probes could be on every single star system of the Milky Way, right? You can start with that. That's a totally reasonable prediction, because even at sublight speeds, there's been enough billions of years, right, for probes to reach every single star system in the galaxy. Now, if you start with that counteracts a lot of the kind of arguments that people give you. And they say, well, things don't move fast enough to visit us. Please factor in time, right? Because time is the fixer of all those problems, right? It doesn't matter how slow it's going if you can give it a couple of billion years to reach, yeah? So I suspect that we're going to mostly be encountering AI out there, and that there's probably all kinds of technologies left by past civilizations and current ones. Now, there are likely to be biological intelligences still there as well out there. And will they connect with each other? I think it's very likely, because again, if their probes are bumping up against each other, right, there's a good chance that these civilizations get to know each other. And if they have technologies like, let's say, near light speed or wormhole travel, or like the Alcubierre drive, this, using warp bubbles where you basically bend space around the craft, you essentially go into time travel, yeah? So when you get into those kind of technologies, you're not only closing the distances, but you're sort of time traveling as well. So if they develop those exotic transportation mechanisms, there's no reason why after probes meeting probes that you can't set up a meeting, right? So I think there's a good chance we're going to find, if we get out there and we contact, or if we are in contact from here, that we'll find that there are networks or alliances or trading, all of that. I think that really is out there. Now, it may be in pockets of the galaxy, or it may be the entire galaxy is networked. Obviously we can only speculate, we can have hints. Obviously people say that they've had contact experiences, and and in that information, if you take it as being valid, often it's described as there's being different kinds of beings that people see. Now, whether those are psychic experiences or some echo from our DNA or what they are, I don't know for sure. But if any of them are legitimate, they tend to point to there being multiple kinds of intelligences they're interested in each other and us. But again, I recognize that those, for most people, are just too speculative. But I do think the contact experiences and what we call abduction are interesting, even if you don't accept them as being alien, because you've then still got to say, why is it that, say, tens or, I don't know, maybe hundreds of thousands or millions of people around the world, right, are having experiences where they feel that they're in the presence of an alien intelligence and that it's communicating with them, usually through telepathy or whatever, and that why is that happening to so many people? Because if that is not contact with another intelligence, shouldn't we want to understand why, say, some of our greatest minds, like astronauts, people in the military, leading scientists, why they would be having that experience? Like, what is going on? Are all these people really crazy? Because they seem to go on with their lives, working, producing for the society and being productive citizens. So it's not a mental illness that we would understand them as, right? Because these are mostly fully functional people. So we should want to know, what's going on here? Let's investigate it. If it's a real psychical contact from another civilization, then hey, let's try and pick up the phone. And if it's not, shouldn't we be trying to find treatment for these people? Right? So either way, but I do think that, that's worth exploring, because it's the only indicator we have about what kind of civilizations are out there. Other than that, we have to speculate and say that science predicts mostly AI, but also the possibility of networked connections between civilizations, just because there's been so much time, and as long as they've got the wormhole tech. And look, just to clarify on wormhole travel, again, most people say that's impossible. Recently, there's been a study done on, could you use black holes to travel? And it turns out that as long as a black hole is large enough and slow enough rotating, that you can pass through the event horizon fairly safely without being ripped apart. And they suspect that the black hole at the center of, of our galaxy, that Sagittarius one, that could be suitable for going through. So where did that go? Maybe that takes us to the Andromeda galaxy or something. We don't know, but could there be civilizations out there that have figured that out, that you can use stable black holes for travel, and they're able to modify them in some way that they can pass through them to specific locations, or that can engineer these wormholes, these kind of, the Einstein-Rosenberg bridges through space-time, that they can pull two locations together. They've developed the exotic materials that are required to open these. Again, we know that in very, speculative theory, that these are possible. So let's say another species has 1 million years more than us, or 10 million years more than us, and they invent this, then they can be anywhere in the galaxy, right? They can be on our moon, they can be, on the other side of the galaxy, they can be anywhere. So I do think we've got to remove the artificial limitations of human level thinking from extraterrestrials, because I see it all the time. People say, we can't do that, or we wouldn't be able to get there fast enough. You've got to stop thinking like that, innit? Because in 1 million years, we won't have any of the problems that we're thinking about now, right?
I think you got a point, man. It really does come down to the part I like about this entire conversation is you are very self-aware in the idea that at the end of the day, we should experiment with everything. We should research everything, and to take, what, in your words, radical ideas, and put them through scientific rigor. If we come out on the other end and they're disproven, then they were simply incorrect thesis, right? But if we come out the other end and they end up being valid with supporting evidence and kind of widely accepted, then they were just simply a new idea that hadn't been realized yet, right? And so we, the human race is incentivized to explore all of these radical ideas, and then to ensure that we put it through that scientific rigor. And so although you probably don't get nearly as much attention on the work that you're doing as you'd like, I think that it's important work, and there should be many, many more people like you that are not only working on the same types of problems and thesis, but also should have their own radical ideas to go out and to explore. So
just to add as well, quickly as well, keep in mind that the TTSA, To the Stars with Tom DeLonge and these guys from the government that are working together, who are behind all of these big articles, they're basically saying the same sort of thing that I'm saying. Look, they're saying that there is a genuine phenomena, right, behind these craft and objects in our skies, that they may be extraterrestrial. They're saying they've got material from these that they think is engineered, not on this world, right? They're telling us as well that if you look at Tom DeLonge's books, his Secret Machines books, he claimed that it's likely we were engineered by extraterrestrials, right? All the things that they're saying, which are in the major press, which people are seeing, I'm saying, but the major difference, right, is I'm giving physical evidence. I've got physical debris, which has been well tested, right? I've got the genetic anomalies, again, they've been well explored. So I'm actually, the irony is, because I'm not famous and because I don't have millions of dollars to get a PR team, right, people won't know of my work. But I'm actually offering testable, right, evidence, whereas they're offering quite speculative evidence at this point. We've got pictures of what looks like a stone, and we're getting told that they have this other evidence, which we haven't seen. But I'm actually saying, well, look, I'm putting it out there. I'm saying, well, look, this is the, I've got another book coming out, but I put it out there already, that these are the anomalies. This is where they are. This is the material. It's tested. It's already been tested. But it's quite strange that, one is getting the New York Times because of who it is, and the better evidence is virtually unknown because I'm not as famous and I don't have the finances to pay a PR team to put this in the New York Times, basically.
For sure. Well, look, and I think that, again, it comes down to you've got so many people who are all hitting on the same thing or around the same thing that, eventually we end up making a breakthrough, and in my personal opinion, what you said earlier just rings so true. There are two existential questions that every single human in their lifetime will ask. The first is there life after death, or is there some sort of environment after death? And the second is, are we alone? Are we the only intelligent life form here, or are there others? And I think that the work that you're doing to focus on that latter is important. And frankly, look, if you or somebody else is able to concretely establish that there is intelligent life somewhere else outside of Earth, it'll be one of the greatest scientific breakthroughs of our life, right? And so it's only crazy and wild and kind of taboo until it's proven to be true, right? And I think
absolutely, absolutely.
Roger Bannister, no one broke the 4-minute mile, and then once one person did it, everyone did. And it'll take one scientific kind of discovery with full documentation and kind of passing of the scientific rigor. And all of a sudden, it will be a known fact that, yes, there is other intelligence out there. We are not alone. And that'll open up a world of possibilities and frankly, capital that will be invested to go explore and find out more. So, keep going.
Thank you. Yeah. And obviously, anyone who partners with me at this stage, I think they may find their name on one of the biggest discoveries in human history, because I've not as yet had anyone be able to explain away the evidence, put it that way. There's, if the scientists want to try, I'd love to have more scientists look over what I'm saying. If they can find the holes, great, right? But if they can't, or they validate it, then hey, this is a paradigm changing event.
For sure. Where can people go find more of your work, either the books or anything else that you're working on?
Sure, I have a couple of websites, brucefenton.info and ancientnews.net, and basically just find me on Facebook, on Twitter. I'm currently as well, I'm a recurring guest expert speaker on Ancient Aliens on the History Channel. Thankfully, Giorgio kind of likes my work, and he's asked that I come on, so I'm now recurring on there. And I should be at Contact in the Desert next year, 2020, to present there. So people can contact me. Twitter is where I'm most active, but they can contact me through my websites, Facebook. I'm quite happy for that.
Got it. All right, Bruce. Listen, I really appreciate you taking the time. We recorded for almost 2 hours, so I know your time is valuable, and I just appreciate you coming on and kind of talking through a lot of this stuff. There's a lot of folks who are interested from hearing from you. So thanks so much. And as you continue your work, we'll have to do this again in the future.
Great. Thank you very much. And I really appreciate, taking the time, and that you took the time to look at some of the papers I sent you and everything. So I'm really pleased that you brought me on. It's been a really good chat. Thank you.
Hey, everyone. Pomp here. If you like this episode of Off the Chain and want to help us take crypto to the top of the Apple, Spotify, and other podcast charts, please do us a favor and rate, review, and subscribe. To review, simply go to the Off the Chain homepage, scroll down until you see the 5 blank stars. Taking 15 seconds to fill those stars in and leave a quick review goes a long way in helping us take the entire crypto ecosystem to the top of the charts. I appreciate you listening, and see you next time on Off the Chain.